Graphs of equations, intercepts, and symmetry. Let's find the intercepts and graph the equation, then indicate whether the graph is symmetric with respect to the x-axis, the y-axis, or the origin. We're going to start simple at first with the linear equation. Y equals 2/3 x minus 3. So the minus 3, this is in the b spot if we're looking at y equals mx plus b. So that is our y-intercept. If we write it as a coordinate, our y-intercept would be 0, -3. Our x-intercepts, we find that by substituting 0 in for y. So 0 equals 2/3 x minus 3, and we'll solve for x. We will add 3 to both sides and get 3 equals 2/3 x. I can multiply both sides by 3 to get rid of my fraction. 9 equals 2x. Divide both sides by 2, and x equals 9/2 or 4.5. So our x-intercept is 4.5, 0. We have 3 types of symmetry that we are going to check for in a moment, and we can also look at the graph to check for symmetry as well. I've labeled that our graph, we've got each grid line representing 1. So to graph this, our linear equation is already in standard form. Let us plot the y-intercept. So I put a point at -3 on the y-axis. My slope is already written as a fraction. It's 2/3. So I will go from that y-intercept, from that point we have already, I will go up to and write 3 and put my second point and draw my line. So this is the graph of my line. So the first symmetry we're going to look at algebraically is whether this graph is symmetric to the x-axis. In order to do that algebraically, we will substitute in the opposite of y everywhere we see y in the original equation. So doing that, we get the opposite of y equals 2/3 x minus 3. So I want to put this back into standard form, or y equals form. Divide everything by -1. Y equals -2/3 x plus 3, which is not the same equation we started with. So because of that, that means that this is not symmetric to the x-axis. And looking at our graph, that makes sense. If we were to imagine reflecting this graph over the x-axis, would it look identical to the original graph? No, this graph is not symmetric to the x-axis. Okay, let's look at y-axis symmetry. To check this, we will substitute in the opposite of x everywhere we see x in the original equation. So y equals 2/3 times opposite of x, or -x minus 3, which simplifies to y equals -2/3 x minus 3, which again is not the same as our original equation. Again, I'm always going back up to my original equation. So because it's not the same, that means that this graph is not symmetric to the y-axis. And looking at the graph, that again makes sense, because if we can imagine folding our graph on the y-axis and reflecting this graph over that y-axis, the resulting graph would not be identical to what we have. Okay, there's one more type of symmetry that we're going to check, symmetry with respect to the origin. To check this, we will substitute in the opposite of y everywhere we see y, and the opposite of x everywhere we see x. And we get the opposite of y equals 2/3 times the opposite of x minus 3, where opposite of y equals -2/3 x minus 3. Let's divide everything by -1. Y equals 2/3 x plus 3. So because of that plus sign, this is not the same as the original equation. So again, this is not symmetric with respect to the origin. We could also see that by looking at the graph. Now, it's harder for me to do this via video, but if you can imagine rotating this graph, so like putting a point at the origin and rotating it 180 degrees, would the graph that we would be looking at look identical to what we are starting with now? No. If it did, then we would be symmetric with respect to the origin, but we are not. Okay, let's look at finding the intercepts and graphing the equation for y equals negative x squared plus 4. And then we'll indicate whether the graph is symmetric with respect to the x-axis, the y-axis, or the origin. So basically the same steps. So here, let's find our y-intercept. We can substitute 0 in for x. So y equals the opposite of 0 squared plus 4, or y equals 4. So my y-intercept is 0, 4. My x-intercept, I'll substitute 0 in for y. So 0 equals negative x squared plus 4. I'll add x squared to both sides. X squared equals 4. Take the square root of both sides. X equals plus or minus 2. So we have two x-intercepts here. Written as a coordinate, those would be 2, 0 and negative 2, 0. Let's look at the graph. So we can plot our y-intercepts. We can plot our x-intercepts. I have a couple other points plotted in between. And I can draw in my parabola. That is opening down. Checking symmetry for x-axis symmetry. Again, we're substituting the opposite of y in everywhere we see y. So the opposite of y equals negative x squared plus 4. Dividing everything by negative 1, y equals x squared minus 4, which is not the same as the original equation. So this is not symmetric to the x-axis. And that makes sense if we look at the graph. We have a parabola, and if we imagine reflecting the parabola over the x-axis, we would have a parabola opening up with the vertex at 0, negative 4. So it would not look identical to what it does now. Y-axis symmetry. We will substitute in the opposite of x everywhere we see x. So y equals the opposite of x squared plus 4, which simplifies to y equals negative x squared plus 4, which is identical to what we started with. So this is the same, so it is symmetric. And that makes sense because if you look at the graph that we have and imagine folding this graph on the y-axis, it would fold onto itself or would reflect onto itself. So this, we can see from the graph as well, does have y-axis symmetry. Let's check whether it's symmetric with respect to the origin. Here we will substitute in both the opposite of y everywhere we see y and the opposite of x everywhere we see x. So the opposite of y equals the opposite of x squared plus 4, which simplifies to the opposite of y equals negative x squared plus 4. Divide everything by negative 1. And we have y equals x squared minus 4, which again is not the same as the original, so it is not symmetric with respect to the origin. And if we were to imagine rotating our graph 180 degrees with the rotation point at the origin, we would not have the same graph. So it would be a graph that would be opening up, so it is not symmetric with respect to the origin. So it is only symmetric with respect to the y-axis. WRT is my abbreviation for with respect to. Okay, let's find the intercepts and test for symmetry of y equals the cube root of x. So for the x-intercept, substitute 0 in for y. 0 equals the cube root of x. Okay, to solve for x, we will cube both sides. 0 equals x, or x equals 0. So as a coordinate, we have 0, 0, which is the origin. Y-intercept, we will substitute 0 in for x, so y equals the cube root of 0, which is 0, so y equals 0. And again, our y-intercept is the origin. So the same point, the origin, is both the x-intercept and y-intercept for this equation. Checking symmetry, let's check x-axis symmetry. So I'm substituting in the opposite of y for y, and we get the opposite of y equals the cube root of x. Dividing everything by -1, we get y equals negative cube root of x, which is not the same as what we started with. So this is not symmetric with respect to the x-axis. To check y-axis symmetry, we are substituting in the opposite of x for x. So y equals the cube root of the opposite of x. Okay, this simplifies to y equals negative cube root of x. The easiest way for me to show you why this is true is to show you an example. So for example, if we were doing the cube root of 8, what does that equal? I didn't put the cube root. Cube root of 8, that equals 2. If we had the cube root of -8, what times itself again is -8? That would be -2. This is true for any value of x, so I can pull the negative outside of the radical. It's kind of like when we're simplifying radicals. We can separate this into the cube root of x times the cube root of -1, and the cube root of -1 is -1. Okay, this is not the same equation. We're back here to what we started with. So it is not symmetric to the y-axis. Let's check the origin. So we are substituting in both the opposite of y and the opposite of x. We have the opposite of y equals negative cube root of x. Divide both sides by -1. Y equals the cube root of x, which is the same equation that we started with. So this equation is symmetric with respect to the origin. One more. Let's find the intercepts and test for symmetry for y equals 3x over x squared plus 9. To find the x-intercept, we'll put 0 in for y. So 0 equals 3x over x squared plus 9. If I multiply both sides by x squared plus 9 to get rid of the fraction, we get 0 equals 3x. Divide both sides by 3, 0 equals x. So 0, 0, or the origin, is our x-intercept. To find the y-intercept, substitute 0 in for x. We have y equals 3 times 0 over 0 squared plus 9, which simplifies to y equals 0. So again, the origin is the y-intercept, and it served as both intercepts here. Checking for symmetry, checking for x-axis symmetry by substituting in the opposite of y, we get the opposite of y equals 3x over x squared plus 9, dividing both sides by -1. Y equals negative 3x over x squared plus 9. This is not the same equation that we started with, so this is not symmetric with respect to the x-axis. Let's check y-axis symmetry. Let's substitute in the opposite of x for x in both places that we see x. So here it simplifies to y equals negative 3x over x squared plus 9, because the opposite of x squared was x squared. This again is not identical because of that negative, so it's not symmetric to the y-axis. Let's check symmetry with respect to the origin. We'll put the opposite of y in and the opposite of x in. So we get the opposite of y equals negative 3x over x squared plus 9. Divide both sides by -1. We get y equals 3x over x squared plus 9. So this is symmetric with respect to the origin, because again, we ended up with the same exact equation that we started with.